Hey guys, it's Udbhav from Team 19343. This video is a continuation of my FTC programming course in Android Studio. Today's video will be on the Mecanum drivetrain. I personally believe that the Mecanum drive is the most efficient and useful drivetrain which your team should also incorporate into your bot. This video will include what a drivetrain is, what differentiates the Mecanum drivetrain from other drivetrains, its abilities, and how to code the same. This code will be done in linear auth mode. Firstly, let's understand what a drivetrain even is. The drivetrain is essentially the legs of the robot, facilitating movement across the game field. The drivetrain generally consists of four wheels and motors, though some drivetrains can have anywhere from six to three wheels. The drivetrain moves in a way similar to that of a car or an automobile. Obviously, if you can't move, you can't win. The drivetrain is an essential part of the robot on which a majority of the other smaller components sit. So this requires the drivetrain to be built in a strong and stout manner. Like just take a look at our center stage bot. It's like a solid box of pure metal. You might be asking, what's up with those weird looking wheels? Those are the Mecanum wheels, giving the drivetrain the name of Mecanum drive. Let's understand what makes the Mecanum drive so efficient and how it works. Take a look at this diagram on screen. This image shows the numerous ways in which the Mecanum drive can move across the field. I know, it looks like a hell lot more than what your average car can do. As you can see, the Mecanum drive allows the whole robot to strafe, which essentially means to move in a direction without facing the bot towards that same direction. This allows for side-to-side and diagonal movement while still facing in a forward manner for the main robot in the desired direction. This allows for extremely efficient driving and execution from the robot controllers and driver, and overall acting like a movement buff in a video game. This movement is achieved by specifically designed Mecanum wheels, which have multiple angled rollers for wheels, allowing for strafing to occur. Now that we know what the Mecanum drive is, let's dive into the two types of Mecanum drive, the robot-centric and the field-centric. Robot-centric can be considered to be base Mecanum drive, in which all strafing movements are relative to the direction in which the robot is facing. So for example, if the robot is facing north, strafing will occur facing north. If the robot is facing east, then strafing will occur facing east. However, in field-centric Mecanum drive, the strafing joystick controls the direction relative to the field and not the robot. This is done by having the X and Y components of the joystick rotated counter to the robot's angle, which is given by the IMU. While this is a fairly complex topic involving higher levels in math and physics, which you can go to the GM0 link in the description if you want to know the entire explanation, all you really need to know is that whenever a certain button is pressed to reset the IMU, that is the direction in which strafing will occur. So for example, let's say we start with the robot facing north, reset the IMU, and turn the robot to east. So now when we strafe, the bot will strafe relative to north, not east, in which the robot is facing. This may be more intuitive and useful for drivers and allows for certain actions to be performed quicker. Alright, so now we know the two different types of Mecanum drive. Let's move on to coding the same. Alright guys, so let's start off with the robot-centric Mecanum drive. And firstly, we need to initialize our motors, obviously. So here we go, use what we learned last class. You can name them anything you like, I just named them like this for convenience sake. So next step, we need to reverse one side of the drive. So we're going to do a little bit of trial and error here. So let's say we reverse the right side and you pull your trigger down and it goes forward. So obviously we need to reverse it to the other side. So instead I'll do front left and back left. So next, let's create doubles Y, X, and RX. Okay, so double Y basically stands for gamepad 1, the left stick Y, so the Y axis of the left stick, double X, the X axis of the same left stick, and RX representing the right stick X. So these will allow us to elegantly code in the Mecanum quality of strafing without hard coding each and every expected movement pattern. Finally, let's also create doubles front left power, back left power, front right power, and back right power, in which we will add and subtract the above doubles for joystick movement to create the desired movement pattern. Remember, each double is set to a certain gamepad movement. So for example, this Y is left stick Y. With that, we have the robot-centric Mecanum drive. So let me just take it from the top here. I'll scroll slowly. If you guys want to screenshot anything, feel free, or if you want to write it up, feel free. All right, so now let's begin with the field-centric Mecanum drive. All right, so now let's discuss the field-centric Mecanum drive. Field-centric is a little bit tougher to explain than robot-centric, so that's why I'm here at the GM0 website, to give you guys a better understanding. First, let's understand this IMU part. An IMU is an inertial measurement unit and is used in smartphones and VR headsets to track the motion of an object. In our case, it tracks the orientation of our bot. So hence, when we click whatever button it is to reset the IMU yaw, the bot's internal IMU reading sets to 0, giving a new direction of strafing for the code to execute. So for example, let's take our bot facing north and reset the IMU and turn east. The bot will strafe as though the bot was still facing north, and this is due to the IMU reset. Next, we need to rotate the direction counter to the bot's rotation, which is given with this little bit of math. It's pretty complex. I'd say you need to be like 11th, 12th standard to understand this. But even if you're not, like me, I'm only in 10th class, we can still just keep this in our code. It's okay if we don't fully understand it for now. We can just insert it in our program. And that should be it. Just add these parts of the code to your existing robot-centric code, and you have coded the field-centric Mecanum drive. Here, let's go to the final sample. I'm going to scroll through this slowly, just check where everything goes. It goes above the wait for start, it's part of the code. Then here, underneath while op mode is active, if whatever, you can choose whatever gamepad option you would like for here. So you could do gamepad 1.a, whatever you feel like. Here's our rotating the movement counter, our double bot heading for our math. And that's it for the field side Mecanum drive. That's it for today's video on the Mecanum drive. I hope that I convinced you to give the Mecanum drive a chance on your own robot, as I really believe that it is the most effective drivetrain out there. But the math and physics behind the Mecanum drivetrain is quite complex. If you want further insight, just head to this link, this exact website. Has all the math behind the Mecanum drive, as you can see, our diagrams, force vectors, if you're still interested in that. So yeah, this is Ludwig from Team 19343 signing off.